mathematics resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Welcome students to S. Chand Academy. In the previous lecture we did complex numbers. In this lecture we are going to do progressions. First we will see some important concepts of progressions. So first, arithmetic progression, which in short is called AP. So a series which is of this form a plus d, a plus 2d, so on, is called an AP. Why it is called an AP? Because there is a common difference of consecutive terms. If you subtract second with first, third with second, fourth with third, you will get a common difference. And if you come to the last term, that is nth term, that will be a plus n minus 1d. So this is the last term, a nth term. Now if you want to find the sum of these n terms, there is a formula which says n by 2, 2a plus n minus 1d. Also you can say n by 2 into a plus last term, which is the nth term, or also you can call it as L. Next we have properties of AP. So basically when we come to properties of AP, first property is that if you add with a constant to each term, it will still be an AP. So first term plus k, second term plus k, third term plus k, you will get an AP, and its common difference will be equal to the common difference of the original AP. Now if we subtract with k, then also it will be an AP with common difference as the previous AP. If you multiply with a constant term k, then also you will get an AP. Only thing is here that there is a common difference, which is k times of the common difference of the original AP. Similarly, if you divide by a non-zero k, then also it will be an AP, and here the AP will be having the common difference as common difference of the original AP divided by k. So these are some of the properties of AP. Now there are means of AP, arithmetic mean. What is an arithmetic mean of AP? So if you take two terms A and B and you talk about their arithmetic mean, which generally denoted by capital A, it is A plus B upon 2. This is the arithmetic mean of AP. And if you want to find n arithmetic means between these two AP, generally we denote it by capital letter, not by small. So I will also denote it by capital letter, the AM actually, A1, A2, AN. These are the arithmetic means between A and B. How many arithmetic means? N arithmetic means. So this will form an AP. If there are n arithmetic means between A and B, then the resultant series is an AP. Now if you talk about the last term and the first term, so there are total n plus 2 terms in this AP. So when you find out the arithmetic mean, it will be something like this, that A1 is equal to A plus B minus A upon n plus 1, and A2 is A plus 2 times of B minus A upon n plus 1, and it will proceed similarly. Now if we ask that there are n terms and any type of n terms, and you have to find its arithmetic mean, then its arithmetic mean is A is equal to A1 plus A2 plus dot 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 plus An upon n. So see, these are some of the basic recaps of arithmetic progression. First of all, its definition, its sum of n terms, nth term, then properties, then we have arithmetic means. Arithmetic means are of these three types. First of all, arithmetic mean between two numbers. Second is n arithmetic mean between two numbers. Third is if n numbers are given, then find the arithmetic mean. Next, which we have to see here is called geometric progression. So geometric progression basically is again defined that consecutive terms are having common ratio. So if we talk about common ratio, that is generally taken as R. So we take the terms as AR, AR square, so on. And if we come to the last term, it is AR to the power n minus 1. This is the nth term. And what is R? R is the common ratio. And what is A? A is the first term of this GP. Now, what is the sum of the GP? Sum of GP is equal to A into 1 minus R to the power n by 1 minus R, and R is not equal to 1 in this case. This is the sum of the GP till n terms. Now, if it is asked to find the sum of the GP till infinity if R is less than 1 or mod R is less than 1, that is the common ratio is between 1 and minus 1, then sum till infinity comes out to be A upon 1 minus R. The condition here is mod of R is less than 1, that is the common ratio magnitude is less than 1. That is a converging GP, then only you can find its sum, otherwise its sum cannot be obtained. Now, after knowing sum till nth term, sum till infinity, we come to properties. So, if we come to properties of GP, what are the properties basically? So, first property is that if you multiply by a constant term which is non-zero to the each term of the GP, resulting will also be a GP. Second, if you divide by non-zero to each term of the GP, resulting is also a GP. On addition and subtraction, it does not follow. Like in AP, addition, subtraction, multiplication and division, all the four conditions will give you AP. But here only multiplication and division will give you GP. Addition and subtraction will not in generally give you any such sequence. Now, third property is that if you take log A, log B, log C, let us suppose, and you say that these are in AP. So, if these are in AP, what does it mean? It simply means that 2 times of log B is equal to log A plus log C. This is the condition for AP, which implies that B square is equal to AC by the property of log. So, you can say that A, B, C are in GP. So, this is a very important property. If log A, log B, log C are in AP, then A, B, C are in GP. First, next we have to also know that if we take, this is an extra point which I am giving you, in arithmetic progression, if there are 3 terms in AP, we generally take for the ease of calculation as A minus D, A plus D. If 4 terms are there, we take as A minus 3D, A minus D, A plus D, A plus 3D. If in GP we have 3 terms, we generally take them as A by R, A, AR. Similarly, 4 terms are there, we take as A by R cube, A by R, AR cube. So, these are the properties. Next, we have to also know the geometric means. So, what are the geometric means? Let us come to that. Geometric means formula are also similar to arithmetic means, as we have seen. So, geometric mean is basically geometric mean between 2 numbers A and B. Then we also have geometric mean, n geometric mean between A and B. Similarly, we have others also. So, let me write it here. Geometric mean. So, if we say that there is a geometric mean between A and B, so that geometric mean is represented by G and it is equal to square root of AB. If I say that there are n geometric mean between AB, so A, G1, G2 till Gn, comma B, this will form a GP. So, in that case, G1 is equal to A into common ratio of the GP, which will be B by A to the power 1 by n plus 1. I am not going into its derivation, you can see in the book, and please like, subscribe the channel and share it with your friends if you like it, and click the bell notification. G2 is equal to A, B by A 2 by n plus 1. Similarly, other geometric means you can find. If you are interested in finding geometric mean of n numbers, then how will you find it? That is a1, a2, so on till an and its nth root. This is the geometric mean of n numbers. Next we have is harmonic progression. So harmonic progression of n terms a1, a2 till an is called harmonic progression if and only if 1 by a1, 1 by a2, 1 by an are in arithmetic progression. So the reciprocals are in AP, then the terms are in HP. And from here you can find the nth term, you can find the harmonic mean and all. Let me find you two things for you. Like if it is an AP, n is equal to 1 by a1 plus n minus 1d. D is the common difference of the AP, corresponding AP. So this will become a1 minus an by a1 an is equal to n minus 1d. And then you can say that the common difference is equal to a1 minus n upon a1 an into n minus 1. So this is the common difference of the corresponding AP. Now you can find a1 by a2. So if you are interested in finding 1 by a2, this is 1 by a1 plus d, which is a1 minus an upon a1 an into n minus 1. From here you can find a2. How will you find a2? You will take the reciprocal. a2 is 1 by reciprocal of this, that is 1 by a1 plus a1 minus an upon a1 n into n minus 1. We generally don't remember the formula when it is needed in the question. As we will see questions also, we will find it out. Harmonic mean. So if it is said that to find the harmonic mean between A and B, then it simply means that A, H, B are in harmonic progression. So if they are in harmonic progression, 1 by A, 1 by H, 1 by B are in arithmetic progression, and then you can find H. So this is how we deal with harmonic progression. There are some important relations between arithmetic mean, geometric mean and harmonic mean. What are those? Please remember these relations. These are very, very important, and it is also mentioned in the book. So G square is equal to H. That is, square of the geometric mean is equal to arithmetic mean into harmonic mean. Also, arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean if A and B are positive numbers. So these two relations are very important to solve many questions which come in competitive exams in JEE. Next, what we have to see here is Arithmetico-Geometric Progression, which is called AGP. So AGP basically are terms which are having one term as the AP, A plus D, A plus 2D and so on, and multiplied with a geometric progression. So B into BR into BR square, like this. So if you come to the last term, it will be A plus n minus 1D into BR to the power n minus 1. So arithmetico-geometric progression is this one, and in arithmetico-geometric progression, each term is a multiple of two terms. One term is forming a AP, another term is forming a GP. You may come across some questions also based on this, and we will see those questions. Next we have here is, after AGP, we have sum of differences. So sum of differences questions will also be seen whenever needed, and we will address those. These are the tools to solve sequence and series questions. Then a special series. So a special series formula is like if it is sum of n natural numbers, 1 plus 2 plus 3 till n. So this will be n into n plus 1 upon 2. If you take the square of these natural numbers and then add them, you will get a formula which is known as n into n plus 1 into 2n plus 1 upon 6. And if you take the cube and then add them, then what you will be getting? You will be getting n into n plus 1 by 2 whole square. So these are some special series which you need to remember, and you will apply these in questions also. Now let us move on. So these theories are some of the recap of the whole chapter of progressions. Now let us come with questions. This is the first question. It says certain numbers appear in both arithmetic progressions 17, 21, 25 so on, and 16, 21, 26 so on. Find the sum of first 100 numbers appearing in both progressions, right? So first we see what are the numbers which are common. So here 21 is the first term, and here also 21 is the first term which is common to both the APs. Next term, which term will be that? So you can see the common difference of this AP is 4, and you can see the common difference of this AP is 5. So when you will take the LCM of 4 and 5, you will get 20, which means the common difference of this AP, which includes the common terms, is actually 20. So you will take next term after 20, 41, and 41 will appear here also, here also. Then you will come to 61 and so on up to 100 terms. Now they are saying that you have to find the sum of 100 terms. So sum of 100 terms is equal to 100 upon 2 into 2a plus 99 into common difference 20. N minus 1 is 99, right? So this will be 50, this will be 42, this will be 1980, and now the calculation part which we have to do, be careful, 2, 12, 2022, so 1 0 will come here, 10, 1, so this will be a number like this, 1,01,100. Now let us move on to the next question of the book. I have taken problem set 1, question number 57. So if A1, A2, A3 are in AP of common difference D, then prove that sum is equal to, like this, is equal to this. So it is a sort of inverse trigonometric function also involved here, and you have to see the cross reference. So what is the cross referencing? That is a formula of inverse trigonometric function. What it says actually is tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. So let us see how we can apply it. So here, as you can see, the sum is equal to tan inverse of d by 1 plus a1 a2. So you write it as tan inverse d can be written as a2 minus a1, right, upon 1 plus a1 a2. Why we can say d is a2 minus a1? Because d is the common difference of the AP, plus tan inverse of a3 minus a2 upon 1 plus a2 a3, so on until the last term, this one we can write it as tan inverse of an minus 1. This is also d. This is an plus 1 minus an, right? The last term is an plus 1 minus an. An minus 1 is also a common difference, but the requirement here is not of that. So an plus 1. So this will become tan inverse of a2 minus tan inverse of a1 by the formula of inverse trigonometric function there. Second one will be tan inverse of a3 minus tan inverse of a2, and so on. The last term will be tan inverse of an plus 1 minus tan inverse of an. Now when we add them, so this is what we call method of difference or telescopic rule. So when you see this, you can see that this is getting cancelled, this is getting cancelled, and so on like this till here, and you will get at the end tan inverse of an plus 1 minus tan inverse of an. So when you calculate this tan inverse of x minus tan inverse of y from there, this will be tan inverse of x minus y, that is an plus 1 minus an, by 1 plus 6y, 1 plus a1 into an plus 1. This is what we will write here. Now what is an plus 1 minus a1? That is n times of the common difference, because this is the n plus 1th term, that is the first term. We know that n plus 1th term is equal to first term plus n plus 1 minus 1 d. So 1 will cancel. You can say that that is in the numerator is d actually. So this is tan inverse of nd, not d but nd. 1 plus a1 an plus 1. Now as you can see in the question, this is what we had to prove. So finally we have proved this. Now let us come to the next question. Find the three numbers constituting a GP if it is known that the sum of the numbers is equal to 26 and that when 1, 6 and 3 are added to them respectively, the new numbers are obtained which form an AP. So first of all, we have to take three numbers constituting a GP. Let us take them as A by R, A, AR. You can also take A, AR, AR square, no problem with that. But generally this makes most of the questions easier. So we make it like this. If it is known that the sum of the numbers is equal to 26, that is A by R plus A plus AR is equal to 26. And that when 1, 6 and 3 are added, so then added to them respectively, the new numbers are obtained which form an AP. So let us add A by R plus 1, A plus 6, AR plus 3. Now this is an AP. So the double of the first term is equal to sum of the first and the third term. So 2 into A plus 6 is equal to A by R plus 1 plus AR plus 3. So this will become, after calculation, here A by R plus AR, and what about 2A? This will come on the right side, that will become minus 2A, and 3 plus 1 4, minus 12 is minus 8, so is equal to 8. So these two equations we have. Now our task is to solve them. So how can we solve them? As you can see here, we can subtract 1 and 2. So on subtracting 1 minus 2, A by R and AR will get cancelled. This will become 3A is equal to 26 minus 8, that will be 18. So A will come out to be 6, right? So this is how calculation becomes easier while taking like this. Now put it anywhere. Let us put it here. So therefore 6 by R plus 6R, this will be minus 12 and go there. So 12 plus 8, 20. So this will become, after simplification, 3R square minus 10R plus 3 is equal to 0. From there we will get the common ratio. So common ratio will come out to be 3 and 1 by 3. Okay, fine. Now you can take both the common ratio, no issue with that. If you take 3, it will be an increasing GP. If you take 1 by 3, it will be a decreasing GP. Terms will still be the same. So find the three numbers. So let us take 3. So when we take 3 and A as 6, the numbers are A by R, that is A by R 6 by 3, 2, and A, that is 6, and AR, that is 18. So this is our answer. If you had taken 1 by 3, then you will get it in reverse order, 18, 6 and 2. Next question, problem set 2, question 45A. If A and G be the AM and GM between two numbers, prove that the numbers are A plus minus square root of A plus G into A minus G. So let those numbers be A and B, small a and small b. So A plus B by 2 is equal to A, and A into B under root is equal to G. From here sum of A plus B is equal to 2A, and from here product of AB is equal to G square. So prove that the numbers are this. Now you have to find A and B. So let us solve them. So when we solve them, we can write it like this: A into B, from B we take here 2a minus a is equal to g square. So this will become a square minus 2aa plus g square is equal to 0. Let me write it clearly. So when you want to find a, the formula will become a is equal to minus b plus minus root over b square minus 4ac upon 2a. So this will become, after simplification, a plus minus root over a minus g into a plus g. So both value cannot be taken for a. So automatically if you take plus 1, then the b will be minus 1, or if you take a as minus 1, b will be the plus 1. So the two numbers are a plus minus root over a plus g into a minus g. This is again problem set 2, question 45b. Construct a quadratic in x such that am of its root is a and gm is g. This is a question which is similar to previous question, and I am giving you the similar question so that you would be able to understand now how to apply it. So first try this question by pausing the video, and if you won't be able to solve it, then continue with the video and see this lecture. Otherwise you can skip this question and move further. So here am of its root are a and gm is g. So am, a plus b by 2 is a, and gm, ab is root over g. This implies a plus b is equal to 2a, and this implies ab is equal to g square. Now if you have to construct a quadratic in x, so if you have to so in this question, if we see that a plus b by 2 is a and ab is root over g, then a plus b is 2a and ab is equal to g square. So x square minus sum of the roots is 2a x plus product of the roots is g square is equal to 0. So as we know that in a quadratic, this is the formula: x square minus sx plus p is equal to 0. So you can move like this. Okay, let us come to this question now. Okay, this question says 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 up to 16 terms. You have to find the summation. So as you can see, the numerator is cube of the natural numbers, and for the first term it is cube of the one natural number, for the second it is cube of first and second natural number. Similarly, in the denominator 1, then 1 plus 3, then 1 plus 3 plus 5. So if you want to see the numerator of a general term, it will be 1 cube plus 2 cube plus 3 cube, so on till r cube. And if you want to see the denominator, its rth term is 1 plus 3 plus 5 up to r terms. Now can you individually know what are the values? In the numerator we studied in a special series that it is sum of the cube. So r into r plus 1 upon 2 whole square. And here when you sum it up, it is an AP. So r by 2, 2 into a plus r minus 1 into common difference is 2. So when you simplify this, 2 and minus 2 will cancel there in the bracket, and 2r into r by 2 will become r square. Now if you see the general term tr, so let us call it tr dash. Now the general term tr is tr dash by tr double dash. So that will be r into r plus 1 upon 2 whole square upon r square. Now r square will cancel simply. So it will become r1 plus 1 whole square by 4 like this. Now this is the general term of this series. Now you have to find the sum till 16 term. So sum till 16 terms will be equal to sigma r plus 1 whole square upon 4, r is equal to 1 to 16. So this would become 2 by 4, 2 square by 4, right? Then 3 square by 4, then 4 square by 4, and proceeding similarly, in the end will be 17 square by 4. So 1 by 4 can be taken as common, but 2 square, 3 square, 4 square, these are square of the natural numbers, not starting from 1, from 2. So let us add 1 square by 4 here and subtract 1 square by 4 here. Now this is forming a series, and 1 by 4 can be taken common. Then this is a square of the natural numbers till 17. So n into n plus 1 into 2n plus 1 upon 6 and minus 1 by 4 at the end. So this will become equal to 6, 3, 18. Now let us do the calculation part. 17 into 3 is 51. 51 into 35. So 51 into 35, if you want to calculate, that will be 5, 25, 3, 15. So 5, 8, 7, 1. So this will be 1785 by 4. Then minus 1 you will do. So 1784 by 4. Now when you will divide, you will get 4, 4, 16. 1, 8 will come. 4, 4, 16 again. And 2, 4 will come. 4, 6, 24. So this will be your answer here. Now let us come to this question. Insert 6 harmonic means between 3 and 6 by 23, right? So let us insert 3, H1, H2, H3, H4, H5, H6 and 6 by 23. This will form an harmonic progression. Now if this is an harmonic progression, when you take the reciprocal will be a arithmetic progression. So let us write it so that you will get a better understanding of how to do questions of harmonic progression. This is an AP. Now in this AP, there are 8 terms. This is the last term, this is the first term. So we can say that the last term is equal to the first term plus n minus 1, that is 8 minus 1, total terms are 8, 6 arithmetic harmonic means and 2 n terms into D. So from here it will come out to be 23 by 6 minus 1 by 3. So 21 by 6 here, which will become 7 by 2. Right, 23 by 6 minus 1 by 3 will be 21 by 6. That will be 7 by 2. 7 by 2 divided by 7. That will be half. So common difference of this AP is actually half. Now if you want to find 1 by H1, so 1 by H1 will be 1 by 3 plus 1 by 2, that is 5 by 6. 1 by H2 will be 5 by 6 plus D, so 1 by 2. So this will be 10 plus 6, 16 by 12, that is 4 by 3. 1 by H3 is equal to 4 by 3 plus half. Common difference will keep on adding, 8 plus 3, 11 by 6. Then 1 by H4, 11 by 6 plus 1 by 2. So on taking LCM, this will be 6, and here there will be 3. 3 plus 11, 14 by 6. That will be 7 by 3. Then 1 by H5. So 1 by H5 will be 7 by 3 plus 1 by 2. So 6 is the LCM again, 14 plus 3, 17 by 6, right? Then 1 by H6. 1 by H6 will be 17 by 6 plus 1 by 2. So this will become, after taking LCM, 6, 7, 20 by 6, 10 by 3. Now how can you know that these are the values which you have obtained is correct or not? So let us also see the 7th 1 by H7. So if 1 by H7 becomes equal to 23 by 6, which is the last term of this AP, then our calculation is correct. So extra 1 by H7 is equal to 10 by 3 plus 1 by 2. So on taking LCM, 20 plus 3, 23 by 6. Yes. So this is actually B. So our calculation is perfectly all right. So insert 6 harmonic means. So this 6 harmonic means, now you take the reciprocal. So this will be 6 by 5, comma 3 by 4, 6 by 11, 3 by 4, 6 by 11, 3 by 7, 6 by 17, 3 by 10. So these are actually, let me erase this is not very clear here. So these are basically the 6 harmonic means. So this will be your answer. So in question of harmonic progression, harmonic mean, you just take the reciprocal and proceed as in arithmetic progression, arithmetic mean, and final answer just take the reciprocal again, and those will be the terms of harmonic progression. If P be the first of n arithmetic means between two numbers and Q be the first of n harmonic means between the same two numbers, prove that the value of Q cannot be between P and n plus 1 by n minus 1 whole square P. So basically we have to find the value of Q here first. So let the two numbers given are A and B, and the arithmetic mean are A1, A2, An. So P be the first of n arithmetic means between two numbers. So if you talk about A1, this they are calling as P. So P will be actually, as we have studied, A plus B minus A upon n plus 1. Similarly, if you take harmonic means, so Q will be the first harmonic mean. So for harmonic mean, what you will do? 1 by A, 1 by H1, 1 by H2, dot 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 1 by Hn, B are in arithmetic progression. The reciprocal are in arithmetic progression. Then this H1 is called the harmonic mean. So first let us talk about 1 by H1. So 1 by H1 is equal to first term 1 by A plus n minus 1 into common difference, and that common difference will be, here it is 1 by B minus 1 by A upon n plus 1. Okay. So similar to arithmetic mean, but there is a concept of reciprocal here. Now from here it will become on taking LCM A n plus 1 into B also. So this will become B n plus 1 plus n minus 1, and this will become A minus B like this. So on simplification further, Bn and minus Bn will cancel, plus B and plus B will add up, or it may subtract. Let's see, 1 by A plus n minus 1. Sorry, there is one error which I have done. This is not n minus 1, this is 1, because you are taking the first harmonic mean, not the last harmonic mean, right? So this is 1. Okay. So when you expand it, you will get Bn, BB will cancel, Bn plus A. So A plus Bn upon BA into n plus 1. This is 1 by H1. So what is Q? Q is H1. So therefore Q is equal to BA n plus 1 upon A plus Bn. Now it is said that Q cannot be between P and n plus 1 by n minus 1 whole square P. So let us also take LCM here. This will be n plus 1. This will be an plus a will cancel, an plus b. Now let us compare this term and this term. Which of them is greater? So if you see, I am not putting any inequality sign right now, I am just putting the two values. So an plus b by n plus 1, which is actually p, ba n plus 1 upon a plus bn, which is q. Now let us cross multiply. So it will become a square n plus ab n square plus ab plus b square n, and this cross multiply. So ba n square plus 2abn plus ab. There will be some cancellation, like ab will get cancelled, or a ba n square will get cancelled, and this you can take on the left hand side. So this will become a square plus b square minus 2ab into n. So this value is a minus b whole square into n, which we already know is greater than equal to 0. So a and b may not be distinct, greater than equal to 0. So that means here it is also greater than equal to 0. Here there is a greater than equal to sign. Here there is a greater than equal to sign. So this was an plus b by n plus 1 p. So therefore p is greater than q. This is what we have obtained. Now q is less than p. So obviously it cannot be greater than p. And this number is even greater than p because n plus 1 by n minus 1 is greater than 1. This n plus 1 by n minus 1 is anyhow greater than 1. So this term is greater than p. So in equation becomes like this: q is less than equal to p is less than n plus 1 by n minus 1 whole square p. So clearly q is not lying between p and n plus 1 by n minus 1 whole square p. Okay. Next question says the sum of first n terms of the series 1 by 2 plus 3 by 4 plus 7 by 8 plus 15 by 16 plus so on is equal to. So what type of series is this? If you will be observing this series, you can see that 1 by 2 can be written as 1 minus 1 by 2. 3 by 4 can be written as 1 minus 1 by 4. 7 by 8 can be written as 1 minus 1 by 8. 15 by 16 can be written 1 minus 1 by 16 and so on. So this, like this. This is how you can write it. So now how many 1 are there? So you have to find till n terms. N ones are there. So it will become n. Minus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 so on up to n terms. So n minus, now this GP will be a r 1 minus r to the power n upon 1 minus r. So this will become, after cancellation, this half and this will also be half cancelled, n minus 1 plus 2 to the power minus n. So n minus 1 plus 2 to the power minus n, C option is the correct option here. So it is, you have to be quite alert to observe the series. The sum of infinite AGP 3, 4, 4 is. So this is an infinite arithmetico-geometric progression. We studied what type of arithmetico-geometric progressions are actually. So you can take them as A, B, A plus D, BR, A plus 2D, BR square and so on. This is 3, this is 4, this is 4 and so on it continues. So can you find A, B, D, R from here? Let us see. So AB is equal to 3, it is okay. From here ABR plus DBR is equal to 4. From here ABR square plus 2DBR square is equal to 4. Now AB is equal to 3, let us substitute in both of them. So this will become 3r plus dbr is equal to 4. And when you substitute 3 here, 3r square plus 2db r square is equal to 4. Now further, let us find db from here or dbr from here. It is 4 minus 3r. And let us substitute here. So this will become 3r square plus 2r into dbr. And dbr from here is 4 minus 3r. So this becomes like this is equal to 4. This is a quadratic in r. So minus 6r square plus 3r square, let us take on the right side 3r square. And then 4 to 8r on the right side minus 8r plus 4 is equal to 0. Now let us solve this. So 3r square minus 6r minus 2r plus 4 equal to 0. So from here 3r common, r minus 2 and minus 2 here again is equal to 0. Right? Calculation I hope is clear to every one of you. Now this is r is equal to 2 by 3 comma 2. Now this is an infinite AGP and its sum has to be obtained. So clearly the mod of r is less than 1. It is hidden that mod of r is less than 1. Then only you can find the sum. Otherwise it will be infinite. So you can't take r as 2. You can't take it as more than 1. So r is 2 by 3. So when you take r 2 by 3, so from here or anywhere from here only db r is 2 by 3 is equal to 4 minus 3 into 2 by 3. So db will come out to be equal to 4 minus 2, 2 cancel, db will be 3. So db is coming out to be 3 and ab is also coming out to be 3. And r is coming out to be 2 by 3. Now let us see the sum of the AGP. Sum of the AGP is AB plus A plus DBR plus so on. If you multiply by R, RS will be equal to AB R. So this will be multiplied with R and put in here. This will be multiplied with R and put in here. So A plus D, B R square, so on. Let us subtract. So this will become 1 minus R into S is equal to AB. When you subtract this, you will get DBR. Next one will be DBR square and so on. When you add them, then AB is separate. All other terms are forming GP. So DBR upon 1 minus R, sum till infinity. So this is D. Now let us put the values. AB, that is 3. DB, that is again 3. Into R, that is 2 by 3. Upon 1 minus R, 1 minus 2 by 3 is 1 by 3. So you are getting like this. So 6 plus 3, 9. 1 second. AB is, 9, fine. It is 9. And then it is 1 minus R into S. So 1 minus R is actually 1 by 3. So S will be 3 into 9, that is 27. Therefore S will come out to be 27. This is option number D. So these were some of the problems and theories of progressions. We will meet you in the next session. Thank you.